afternoon, ladies and gentlemen. And so here is my presentation, and it's about high-low frequency attack and defense toolkit. So today I gonna mention before our presentation, and it's more about how to develop hardware. It's less about how to crack it. So it might be a little bit boring. And so even though I graduated from the electronic engineering university, and I still think this is a little bit boring. And so I will make this as simple as I can and fast. Okay. So here is my agenda, and let's get started. And this presentation is combine all our works from the 360 Unicorn team's work, and we focus on hardware development and the hardware hacking, such as embedded device or IoT system or some car system, and our job is guarantee the wireless security of the Qihoo 360, and we already share our works in DEFCON and POC and Kansai Quest, etc., and about how to fake a GPS signal and how to hack a film to sell, and so on. So if you are interested, just Google it. That's okay. So let's get a quick review about the foreigner, the low frequency and high frequency attack. So how to hack it? There is two ways, and in low frequency, we already, there is commonly some key card used in low frequency, and in high frequency, there is a smart card and a MIFARE classic. That's I believe you guys all already know about it. So when you guys, I don't know if you know about this, and so. Let's just skip to this. So this is the low frequency attack, and in China we got two sniffer and clone, and this tool you can buy it everywhere. So if you want to clone quick card, you can just buy it, and you put your ID card on it, and you press the button so it can clone exactly same ID card. This is common use, but there is some shortcoming in it. It can brute force, and it can change the contact of your ID card. So everything, so it just can all these tools can do is just clone and nothing else. So when I was young, and I want to crack in some access system, and I want to clone an ID card, all I need to do is bring a big laptop and bring a card reader, and of course I need a bag. So this is huge, and it's complicated. So we just develop a new hardware to solve this problem, and it's quite convenient. It's just so you can now crack a access system with your phone and with the hardware that, with this little size. So before we introduce the details of this hardware system, let's talk about how the ID access system works. So this system is the ID card access system usually made up by ID card reader, and the backend controller, and so on. So firstly, the ID card reader will send out the carrier signals by the antenna, and the carrier signals frequency is about the 125 kilohertz. So secondly, the ID cards reach the ID card reader's working area. So the redundant circuit, which is made up by the capacitance and the antenna, receives the carrier signals. So the radio frequency interface module will generate the power reset signals and the system clock by the signal. So activate and then activate this chip. So thirdly, the chip will read the serial numbers from its storage, and then add the serial number on the carrier signals by the phase modulation encoding, and send it back to the reader. So at last, this reader will demodulate this signal and get the numbers, compare it with the database, and choose to open the door or not. So here is the transformation of our product, which we named it the HackID Pro. So firstly, we just make a badge to want to clone ID card. So this is the first one, first version, and all it can do is just put it into between the card and the card reader. So when the card is working, this will storage the signals communicated between the card and the card reader. So it's just basically a cloner. So it can change the serial numbers, and it can such as emulate more than 2 ID card. So the second one is our second version. So this one, it can emulate what you want, and you can put a serial number in it and press the OK button, and they all thing and it can work. So, but this is the little bit shortcoming. It can't burn first, and the only thing it can do is just emulate the serial number you input. So we just developed the third version. The third version is the HackID Pro, and so we made a hardware and plug in your phone, and we also made connected the app, and we type what we want, and it can brute force, it can clone, and it can sniff. Basically, all the low frequency ID card hacking, the method, all this method this app can do. So here is the details of our HackID Pro, and it got 2 models. You can control it by your app. You can work alone, and as you can see in this picture, you can there is an audio connector on it. So when you use it, you can just plug it in your phone by the audio interface. So here is the the hardware details of the HackID Pro. It doesn't matter, so you can just see it. Let's next. Okay. So the HackID Pro's applicable things is pretty much, and you can read and simulate all these protocols. So if you guys know about ID card, you will find out all this ID card protocol is included in this. Basically, include these 5 things, and but if there is any protocol that we haven't know yet, it doesn't matter. We can record and replay it, and so what you can do is just clone all the low frequency card, and whatever is matrix code and is bface code or code, whatever, it all can down. So why do we use the audio connector? This idea is come from the Hijack program from the Michigan University, and it can use power and bandwidth of your phone. So it's self-powered, and it can communicate between your phone and your hardware. So here is the original version of Project Hijack, and you can see it also it is also has a audio connector and a hardware layer. So here is the detail of our audio connector. So the left channel is used to transfer data. To transfer data from the phone to my HackID Pro. So on the opposite, the mic is used to transfer data from the HackID Pro to your phone. So we designed this filter. So we designed this filter circuit to make the simulation voice signal adjust to the digital signal of your MCU. So left channel audio simulation signal after the filter, it has the DC bias. So on this picture, you can see the IN1 plus is on this picture. So it connects to the in-chip analog compactor to get the digital signal. And so the Hijack Pro will output the digital signals through the MCU's I/O, and after the filter, after the DC bias, and get the mic voice signal. So here is the MCU and storage circuit. So the Cortex-M serial chip is the brain of Hijack Pro. It can it can control all. I'm sorry. Here. So it controls all the hardwares and hardware interface, and it processes all the software protocol, and the hardware uses the internal 12 megahertz the oscillator, and as the clock source. So and besides, we use a large storage chip to store original signals, so you can replay them. And as you can see, we use the 521 kilobits. So it's pretty good for it's pretty big if you just want to record a voice signal. So this is enough for us. So there are two methods of Hijack Pro to get power supply. One is micro USB, one is battery. And but as you can see, the IC chip needs 3.3 and 5 volt power supply both. So when we use battery, and it needs a buck circuit to downgrade to 3.3 volts. And when we use micro USB, so there should be a both circuit to upgrade your volt to 5. To 5. And so this chip, RTC3558, that's why we use it. It's quite cheap, and it's easy to use. So in this hardware, we separate the simulator and the real circuit. In simulator circuit, and we use the NPN transistor, and this equipment is how we calculate out the parameters of all the elements that we use in the reader circuit, and we use the EM serial chip to demonstration. Chip to demonstrate the AM modulation, and that sense from the antenna. So as you can see, the hardware design of this Hijack Pro is not quite complicated. So all these things you should notice is the digital and the simulation spread in layout, and you should adjust to the adjustment on the antenna, and the electromagnetic oscillation. That's all things you should notice. But if there's some hardware designers, in you guys, I believe all these things is quite easy to him. So after the hardware design of Hijack Pro, let's talk about the software design of Hijack Pro. And why we use the Cortex-M is it's pretty low power, and so the more time that we can use, and the more time the Hijack Pro will stand by. So we split the subroutines in these 4, and so it's just a quick view of it. So when you record the there is a lot of ID card protocol internals, such as the Hijack, the EM protocol, and as you can see, the TK version. So it's commonly used in China. Basically, it's about 80% low frequency ID card is use this protocol in China. So let's just quick example. Okay. So here is the protocol. Here is the protocol of the TK 41000, and all this database is 64 bits, and include 9 star, as you can see. Okay, just say that I don't need to repeat it. And so when the card is closed by the when there is ID card is close to Hack ID Pro, this software will demulate the 125 kilohertz signals. So after the demulation and the software decodes this the final data that we got will exactly the same as you can see in these lower pictures. The details is about 8. So this protocol uses the Mantress code. I don't know if you guys know about the Mantress code, but it's the rising edge means the 1 in Mantress code, and the falling edge is 0. And so after you decode by the Mantress format, there will be some data parity check. So if you want to design a software in this sense, the data parity check algorithm is important. And here it is. I don't know if you guys will see it clearly. If it doesn't matter. So when you want to simulate a card, and the principle is opposite from the reading. So you can transfer the data into the into this pictures format, and the MCU will process the lowest of the lowest bit of this format, and format into Mantress code, and output it bit by bit. And so once there is some ID card around it, and it can read out the simulated signals, and the brute force. When we use the brute force function, so what you need to do is just increase the ID and output it again, in Mantress format. So when you want to clone a card, as you can see, as we mentioned before, there's a lot of formats that we some producer use in ID card. So there is bitface code or PSK code, and some little factory that they use, but it doesn't matter. It's ID card, so just keep it simple. We can just record it and store it in our ROM, and when we need it, we just get it out and play it. That's okay. So here is the communication picture and routines of the Hack ID Pro, and as you can see, the Hack ID Pro uses the Mantress code to combine the communication between the app and the Hack ID Pro. So the left channel is used to transfer the data from the app to Hack ID Pro, and the valid data is packaged in a small little packet. So the Mantress line will use to use this database to decode it, to code it, and in Hack ID Pro, a competitor will be used to transfer the simulate data into the digital data, and the hardware decoder will decode this Mantress bit data flow, and keep processing this valid data. And as you can see, the left channel is yellow, and the right channel is after the compactor. This is the blue line. So this, if this will be big, you can see it's the valid data of this picture is 0672. And I will share this slide into you if you guys want to know about the details. So the communication between the from the HackID Pro to your app is similar to the app to HackID Pro. And it's also the big flow, and the differences is we use the RC filters, and so we remove the DC bias. And besides the app, when the app checks the mic, and it uses the edge detections, it's quite easy. And besides, this might be a little bit difficult if you first if this is the first time you listen about some hardware presentation, but don't worry, we already upload all these source code and the PCB layers on the GitHub. So if you guys want to know the details, so after this presentation, you're welcome to clone or fork or pull a request on the GitHub, and I will give the address of it. And so here is the demo of HackID Pro. So this is the color reader. As you can see, we just use is a regular ID card. So here is the standalone model, and now we just press the button and keep it closed on the ID card, and this is how it's recording. Now it's blinking. So when it's blinking, it means this HackID Pro is processing the data. So when it stops, it means it already done. Let's take a little bit time. Okay, here it is. So this is standalone model, and when you put the HackID Pro near the color reader, you can see the contact exactly the same. So here is when we use the app model. So when you use the app, you can just read it, or you can see the digital changed, and exactly the same with the number on the screen. So it means it can read the content out, and it just press the simulate button, and so it can simulate the SIM card. And besides, this is the brute force model, so you can just increase the ID and make it out. And if there is another serial number you want to type out and want to clone, just type it and emulate. You can see it's exactly same with where we just typed. So here is the HackID Pro. And what about the future of HackID Pro? As you can see, this is just a low frequency. It's just a low frequency clone and sniff and simulate and brute force. But we are trying to we are doing our job to combine the high frequency into it, such as to clone Mayfair Classic and to clone another 30.56 megahertz. This card, or this here is the funny and amazing things the Dutch Germany made. It's called Chamberlain Mini, and I think it's amazing. But its shortcomings still you should use a laptop. It's not convenient, and so we are trying to combine these functions into the HackID Pro, and so this now you can just hack into an access system with your phone and your little bit things, and you don't need a laptop or a tablet. It's quite big. So after the HackID Pro, and it's low frequency, and so we talk about the high frequency. The high frequency, you can see your card now there is some chip and pin card. It's called EMV. Such as the Apple Pie, but the Chinese version of EMV is the PBOC, is PBOC, and it's So in the DEFCON or in the Black Hat, there is formally a lot of research about this, how to clone, how to replay a EMV card or preplay. But in China, it's much simpler, and it's quite easy because you don't need to how to hack into a chip and a pin, and it's a Java machine, and it's not quite easy. But in China, you can just made a reader and read all this EMV card out, and all information is in here, such as your ID, your name, or your birth date, and your ID card, your card name, and the valid date. There's all in it, and it's not encrypted, so you can just read it out. And in some online store, such as Amazon, you can just you don't need to use a CVV card, CVV tool. You can just use these informations, and you can buy everything what you want. So it's quite easy. And how do we read all these information out? So we made a tool to read it out. But in common use, people use Nexus or SAR and OmniKey. So this is quite common. But it's not quite convenient, or it's not quite cool, as I think. So we just made these readers, and the runtime of this hardware is quite easy, and so we just send the command, and we face the response, and in TRV format, and we get all these information out. As I mentioned before, all these information you can just get it out in the TRV format, and it's not encrypted. So why we don't use an Nexus or your phone with an NFC model, and we made a remake reader. So the power of your phone, if you want to read a card, so you need to put it in really close, and so if you want to steal someone's information, it's not convenient. You put your phone near his pocket, and besides the card reader, I'm sorry, that's a tab. The card reader is a lot. It has a big power, but it should use with a laptop, so it's still big. I don't want to hold my laptop to hack anyone. So here is the hardware design details of it. It's much simpler than the Hijack Pro, and so we just use a two chip, and one is to read and one is to transfer the data. And receiver of the this EMV reader is split to two parts. One is the reader and one is the receiver. Your receiver will plug in your laptop or your get an OTG phone, plug in your phone. That's okay. And this will transfer the data from the reader and show it on your laptop or on your phone. That's all okay. And this is a serial port. So the principle is quite simple. The principle is quite simple, and the main chip, the CC serial chip, control this device and connect to the NXP. That's an NXP serial chip. It's a reader chip, and by the SPI protocol, and we send a read command and we face the response, and after all these things, we transfer response to your laptop. That means to your receiver. So what you can get, such as if I put this in near to my credit card, and you can get as I mentioned, your card number, your card holder name, the valid data, and your ID number. So in Amazon, you can buy whatever you want. So here is the sense that we use. We put it into our gloves, and so as you can see nothing. And so we just walk nearby you, and we swipe it. All these information will come out. So here, before we talked about is how to attack. So let's talk about how to defend it. So there is some already have some products to defend. That means a defense tool, such as the RFID wallet. There is a little bit funny, amazing product. That means armor card, and as I don't know if you guys have some RFID wallet. I believe the guy I met before had it, and it's quite good. But some as you know, the RFID wallet is a little bit ugly. All right. So many girls don't want to use this RFID wallet, and besides, the armor card is amazing, and but the shortcoming is it's unchargeable. So when you run out of the battery of this product, so what you need to do is just to buy another one. It's quite expensive. So that's how we made what we made is our card defender. So basically, it's a jammer, and besides, it's chargeable. Besides, the armor card, this one, it can only defend the high frequency. It can defend the low frequency. So we combine these two functions together. It can defend low frequency and the high frequency. So it's this principle of this product is much easier than the two products we mentioned before. So all these things it do is detect if there is a reader, and if there it is, okay, it just send out the signals with nonsense and to jam it. So the major problem of this product is is these things is battery, and if you don't want to charge it every day, and how sensitive that means if there is you work in the ground, you work on the ground, and there might be some readers into it, but it's quite sensitive, so it's always jamming, and so your batteries will be run out quickly. And besides, we want to chargeable, so this product might be sync. So that's a false problem. That's a false problem, and so we should make it to more and more sync. And besides, that's the low battery and the sensitive come out to the fifth problem. That means the low power. So here is our solution. We use this thin battery. That means it's more like paper. It's quite thin, and to solve the sensitive problem, we level up our trigger voltage, and to make this as this should be like a card, as thin as a card, your credit card. So we use a soft PCB. So here is our card defender demo. This is a higher frequency. It's omni-key. It's an omni-key reader, and the back one is the low frequency reader. So the back card is our card defender. So as you can see, the LED on this omni-key reader is not blinking, so it means it didn't work. As you can see in this low frequency, yeah. So when you remove it, it's blinking. It means it's working. Yeah, so here. So the future of the card defender is, if you want to put it in your wallet, and when you take a bus, you don't want to get out. You don't want to. Every time you want, you flash, you tap your bus card. You don't want to pull it out. And so what we want to do is just, when there is a bus card reader, so there is some, I don't know how to pronounce it. some things that there will be only in the bus card reader. So we will detect it, and when we find out it's a bus card reader, so the jammer will not be worked. And this product might be standby about 1 month once charged, and so we just want to make it longer. And there is a little bit trick. So if there is in the market, there will be some device to detect you didn't pay and get things out. But this level on this stuff is either high frequency or low frequency. So if you put these things together and get out of the market, the device won't be alarmed. So if you want to gonna homemade, so all this problem I mentioned before is not quite important, because you don't care if it will be it will be seen as we want to make, and you can use a large battery, and it's not quite as cool as you can do, and so if you want to make your own, so here is our gift. I believe the source code will explain everything. So we just upload all these 3 products that before we use, but because our hardware designer is marrying in his home, so we don't have all the source code together. So we will upload it one by one. Now I believe the EMV reader is on the GitHub now. So you're welcome to fork it and pull request or open issue. That's okay. So as I mentioned, this presentation is combine all our hardware works together. So this is our hardware designers, and here is the end of my presentation. Do you have any questions?
Thank you, Shan Haoqi. Thank you very much.
I've got several questions. On one of them, with the badge reader, when you're doing it in without using the phone,
Yeah.
How do you have to be that close to the contact and for that long for it to actually be effective?
Thomas 能帮我翻译吗？我不太。
The badge contact， 你需要多近的距离？
It's really close. So basically, we just put it on the reader, and it's quite close.
Okay. And the next one, is there a way to actually attach an antenna if you could put it in an enclosure next to a door, it's like to camouflage it, could you put in an extender antenna onto that device?
Hack Pro ID?
Yeah, the Hack Pro ID.
Hack Pro ID 你可以加一个那个天线，就是把它藏起来，然后周围的更那个收视率就会更好。
I believe it's quite difficult because the reader's antenna is it can get a larger power, but the card antenna it don't have so much power to transfer the data back.
In an enclosure, it would be able to extend that. But I'll talk to you a little bit offline too on that. And also, the last most important question: can I buy one now and leave Singapore with a Hack Pro ID?
Buy one now? I believe if you just you can just email me. I think we can email international.
Anyone? Any more questions? No? Okay, Shan Haoqi, thank you very much.
Thank you.
All right.